Hello everyone. In this video, I'm gonna introduce a simulation program related to pneumatics, Festo FluidSIM. FluidSIM is a teaching tool for simulating pneumatics, hydraulics, electrics, electronics, and digital technique. It can be used in combination with Festo didactic training hardware, but also you can use independently. The new version of Festo FluidSIM is FluidSIM 6.0. I've been using Festo FluidSIM 4.0 and 5.0 for maybe 10 years, but this new version is quite different. This tutorial, I'm just show you the interface of the program and the functions, main functions of this simulation program. In the next video, I'm gonna start to use this simulation program in detail. I'm gonna give much more examples in the next few videos. Okay, let's get started. By the way, FluidSIM permits the creating and simulating of circuits in the various fields. For example, electro-pneumatics, vacuum technology, hydraulics, electro-hydraulics, mobile hydraulics, electric engineering, and electronics, so on. This is the login interface. I already enroll and I've got license. Okay, and after that, the program asks you which technology are you gonna use. There are three options: pneumatics, hydraulics, electrical engineering. If you prefer use just one or two of these, you can choose and start to run, but I will check all of them and I need to show you the interface. Okay. Yes. This is the interface of the program. This program is just not just simulation program. You can use this as a drawing program, as a CAD program and simulation program, or you can connect in a real life environment to this program. Okay, on the left hand side, before we start, on the left hand side you can see the library section. Under the library section there are subsections which you can use the components in a different category. For example, pneumatic, hydraulic, electrical controls, and two different electrical control sections, as you can see, IAC and NEMA. IAC, International Electrotechnical Commission, and NEMA is National Electrical Manufacturers Association. One of is based on United States, second one NEMA, and IAC commonly used other than the United States, for example Europe, and other electrical engineering components, and so many things. For example, GRAFCET is a kind of flowchart programming techniques, and you can see here the easy port at physical environment. There's a Festo equipment easy port. You can connect this PC with easy port and you can control the physical hardware on the field. So this section is really important, but before that you need to check most important thing under the manage menu. On the left hand side you can see the setup units. When you click the unit section, you can see these unit systems. You can choose which unit system, you prefer, and FluidSIM automatically converts all the examination in the program automatically. Metric systems and imperial system. Under metric system there are two kind of pressure units: megapascal and bar, and I'm leaving this section like this metric, megapascal. Okay. And there are so many details, but important thing here is using library and using ribbon. You can see this section here. This is not a classical menu bar. In FluidSIM 6, for a clearer, easier operation with fewer mouse clicks, FluidSIM 6 uses a menu ribbon instead of the classical menu bar. You can customize it, by the way, and you can customize keyboard shortcuts, by the way. Okay, and I'm not gonna construct or draw a circuit. I'm just I'm just showing you the interface, and in the next videos I'm gonna give you detailed explanations. So let's show you something. Let's create a new project in a blank page. Yes. On the left hand side in the blank page, you can easily, in a drag and drop movement, you can create a pneumatic circuit. You can see pneumatic under pneumatics section. You can see all the pneumatic components, actuators. There are lots of actuators: single acting cylinder, double acting cylinder, air motor, compressor, fluidic muscles, so many things. Supply elements, directional valve, and you can configure. There are configurable directional valves or pre-constructed directional valves. I'm not gonna explain details. In the next video, I'm gonna explain details. Flow control valves, pressure control valves, measuring instruments and sensors. You can see so many instruments, pressure gauge, flow meter, valve groups, vacuum technology, and proportional valves you can use if you want to use. If you want to construct a hydraulic circuit, you can find all the hydraulic components under these sections. Similarly, in the pneumatic section, actuators, supply elements, measuring instruments and sensors, proportional valves, directional valves, flow control valves, pressure control valves, and mobile hydraulics. It's a different category. Mobile hydraulics is a different category, and you want, if you use electrical components, you can choose whatever you want under the International Electrotechnical Commission sections: electrical control symbols, switches, relays. So many kind of relays you can find under these sections. And if you want to draw a diagram based on the NEMA, National Electrical Manufacturer Association symbols, you can use these sections. And electrical engineering, electronics components symbols under this section you can find: semiconductors, passive components, so many things. So I'm not gonna explain you. I'm gonna switch this. I'm gonna switch off this library section. In a blank page, easily construct a circuit. For example, you can select a single acting cylinder, drag and drop. It's an easy explanation. And a compressor and valve, directional valve, mechanical operated, 3 two-way valve. Yes, that's it. Just drag and drop and connect the lines, pneumatic lines. That's all. And you can simulate it when you push the start button, yes, you can see the dark blue line as a pressure line, and the other is not pressure line. When you push this button, yes, you can see the behavior of this circuit. It's easy to simulate. Okay. But for me, an important thing is this didactic menu. I'm gonna close this project. Discard all changes. Okay, under didactic menu, you can find a lot of didactical materials, videos, explanation, animations. But before that, I'm showing you this section, circuits for exercise. When you click this button, you can see the TP training package for Festo. If you have already a training package from Festo, I'm showing you, for example. Yes. For example, equipment set TP 101 basic level, basic pneumatics training. This is Festo training package. It's an hardware. It's a training equipment, training package, and inside this package you can find so many components. For example, two-way panel mounted with push button actuator normal closed, pneumatic timer normal closed, pressure sequence valve, shuttle valve, dual pressure valve, quick exhaust valve, manifold, pressure gauge, startup valve with filter control valve, and you can see the order numbers. I have already this package, training package 101, 102, 201, and 202. And if you have this equipment set, this training set, you can use this section. I'm showing you again. Circuits for exercise, yes, pneumatics. For example, I've got TP 1.1 pneumatics basics. Yes, you can find all the exercise in this training package. In this training package workbook, in this training package textbook, and you can construct all this circuit in this simulation program as a soft circuit, and in the real environment as a hardware circuit. For example, I'm gonna open this one, and on the background you can see the real circuit which you can construct in a real environment with training package 1.101 with Festo training equipment. Okay. So didactic section is really important. You can find, I'm closing this, you can find so many things under this section. If you have a valid license, in a demo version it's not possible to access this section. Don't forget this. There are some presentations, flash presentations, extended presentations, simulations, videos, and colorful graphics. And when you click these sections, you can find many other tutorials. For example, if you want to study about wave valve, you can click here and you can find a lot of detailed materials, tutorial materials, and it includes animations, by the way. Animation shows the actuating and relays of two-way valve, which causes the piston rod of the cylinder to advance and retract. You can find explanation, you can find circuit diagram, you can find the animation, how it worked. And you can also find educational videos under these sections. Under the didactic material section, you can find educational films. Introduction, pneumatic structure of hybrid systems, fundamentals of electricity, relays, sensors and relays, solenoid valves. You can find so many educational films. For example, I'm gonna play this one.
Pneumatic drives allow linear motion to be achieved. Let's look at a normal. This is the symbol. This limits for it. If the contact remains closed, it is a switch. This is shown in the symbol by a detent. The contact does not break until the switch is actuated again.
Okay, and finally, I just want to show you a pre-constructed circuit. Here, I draw an example. It's an electro-pneumatic circuit. You can see on the left-hand side pneumatic section, power section. On the right-hand side, you can see the control section with two different magnetic proximity switch, magnetic proximity sensors, and there are relays, solenoid valves, and switches. When you play the start button under the simulation, you can see this is a this is not a pneumatic, this is a hydraulic circuit. That's because that's the reason you can see this pressure line not blue. Of course, it can be customizable, but now it's a standard setup. You can see the red or brown. This is a hydraulic pressure line, and the red one is electricity. You can see the flow of the electricity, but there's nothing here before you start. When you push the start, yes, these are current flow. You can see the current flow, and you can see the endless cycle in a power section and in the control section. This is just for presentation, just for representing the interface and main functions of the program. In the next videos, I'm giving you detailed explanation. I'm gonna start some videos related to menus, ribbon, creating a new circuit diagram, creating a new project, organizing projects, symbols and libraries, and editing circuits. I'm gonna talk about editing circuits, automatically connectors, defining properties of the lines, configuring directional control valves, so on. And after that, I'm gonna explain something about drawing frame, page borders, page dividers, and maybe it takes time, but it's gonna be series of video. And I'm gonna explain additional tools for creating drawing, rulers, grid, cross references. And after that, we will talk about simulations properties, simulation features, and I will explain something about advanced concepts in simulating and creating circuits. For example, you can access the force profile, external load and friction. You can simulate these kind of things in advanced simulation options. And with FluidSIM, you can, I'm gonna stop this, yes. With FluidSIM, you can use FluidSIM as an OPC server or OPC client, and you can construct an open loop control pneumatic or hydraulic circuit or closed loop control circuit. And we will talk about later. We will talk about it. And GRAFCET is really important. You can see on the left-hand side here the GRAFCET section. With GRAFCET, you can construct a circuit with, like a flow chart, and you can control the circuit with a kind of flow chart. Okay. We'll talk about later GRAFCET and PLC components, programmable logical controllers. It's really important feature in this version. And I'm gonna talking about tables, reports, functional diagrams, special functions for electrical circuits, so many things. But just in this video, just this quick explanation is enough, I think. So that's all for now. See you in the next video, I hope. Bye.